So in this video, we can look at such a problem. It is an integration problem that involves certain square roots, and the expression inside the square root contains the term x squared minus certain constant. And we can try to use a trigonometric substitution, x equals 7 over 2 times secant theta. And usually, automatically, we should do the second step. The x would be the derivative on the right-hand side, which is 7 over 2 times secant theta times tangent theta, right? D theta. And both of these are necessary. We have to replace everything inside the black integral. So everything should be transformed from x to theta. And there's a key fact here. We need to transform the expression involving the square root, right? So let me put it here. For the square root of 4x squared minus 49, we have to replace x by 7 over 2 times secant theta, right? So we need to transform this a little bit. So we have to expand the whole thing to get this. And I hope you see the reason why I'm doing that. I think first of all, 4 is cancelled. So we are left with the following expression. If you look at the purple expression more closely now, you could notice that the 49 is a common factor we can take out. So once you are arriving at this stage, we understand that the square root of 49 is 7, right? And this part is basically a famous formula, right? It's the identity that contains tangent square theta and secant square theta. It is exactly the same as tangent square theta, right? So altogether, I think we can remove the square root to make 7 times tangent theta, right? Because the blue expression tangent square theta, when you use a square root on top of that, the square is cancelled with the square root. So this purple expression, 7 tangent theta, we have to replace it back to the purple circle here. So let me write down the next step. So now the top, I replace it by 7 tangent theta as promised, and the dx needs to be replaced by whatever we have on the right-hand side of this equation. So let me write it down here. So as you can see, I already replaced the expression in for dx, and the x needs to be replaced by obviously 7 over 2 times secant theta, right? And so let's do the simplification here. Please look at the secant theta. It can be cancelled, right? So we are left with, I think, 2 copies of tangent theta. And the constant can be cancelled here. You see, 7 over 2 can be cancelled with 7 over 2. So we are left with only the constant 7. And we can actually push it out. So I write down the next step. So the 7 as a constant is pushed out, and we are left with 2 copies of tangent square theta, right? And such problem, we don't know the yet immediately, but we just have to try it out a little bit. We have to try something we actually understand about the tangent square theta. I think there's one famous identity we can use. We have seen it earlier in this video, which is the case that when tangent square theta is actually the same as secant square theta minus 1, right? And we can integrate these two terms separately. The second term is going to be minus theta, right? And the first term, you are essentially integrating secant square theta, d theta, which is tangent theta, right? So that's basically the answer in terms of the variable theta. But in general, we need the answer back in x, because if you recall, I was actually asking the problem in variable x. And please recall the transform we use x equals 7 over 2 times secant theta. So what is the correct expressions in terms of x for theta? I think what we can do is we can write it as 2x over 7 equals secant theta, which means that theta, we can use the inverse function of the secant function. So the theta is actually the inverse secant of 2x over 7. So I hope you are with me on this part. This expression is for the theta, which we can replace up here, right? So let me do the replacement just for the second term, which is theta, right? And for the first term, tangent theta, there are a couple of ways you can see how to replace it back based on this transform here, x equals 7 secant theta over 2. One way is like this. Let me copy this down there. So we have an expression secant theta equals 2x over 7. And please recall the identity that we have. Tangent square theta is actually secant square theta minus 1. So we can replace it in, right? So it means that the tangent square theta is actually the same as 2x over 7, the whole thing square minus 1. So we get the expression for tangent theta. Why? Because we can use this, and which means that tangent theta is actually square root of 2x over 7, the whole thing square minus 1, right? So I can replace it in back up here. So let me write it down here. So it's the square root of 2x over 7, the whole thing square minus 1. And you can see that basically that's our final answer. And obviously, if you look at this part, we can write it in a slightly better way. Why? Because we can multiply the 7 into the two terms separately. So when you multiply it in, you can see what happens because the first expressions, we can write it this way. And now, instead of writing it as two terms, we can use a common denominator for 49. So we are getting something like this. And you can see this one as a factor can be pulled out, which is the factor 1 over 7. So we are having an expression like this, and this 1 over 7 can be cancelled with the 7 outside. So it means that these expressions, when you multiply the 7 in, this is an expression exactly the same as this, which is the square root of 4x squared minus 49. And the second expression, please don't forget to multiply 7 in, which is 7 times the inverse of secant function of 2x over 7. And that's basically the final answer to this problem.